Hi my dear student, today we will discuss about trigonometric function. Very first we are going to talk about sine function and whose reciprocal cosecant. Later on sine inverse x and cosecant inverse x. So very first let us see about sine curve. This is what sine curve. It will be like this in a wave motion. See, your sine 0 is 0. So when x is 0, I will consider y equal to sine x. Y is a function in terms of x, which is sine x. Okay, where x is the domain, y is the output or the range. So when sine 0 0, it goes up sine 30 1 by 2, sine 60 root 3 by 2, etc. Sine 90 degree, it gives 1. And it comes down sine 180 degree, it will be 0. And when you proceed further, sine 270 degree, 3 times 90, that is 270 degree, it gives minus 1. And it goes up 360 degree, that is 2 pi, it gives 0. This is what sine curve. 0, etc. 90, 180, 270 and 2 pi, that is 360 degree. This is what one complete cycle. This is what one complete cycle. And either side of the curve, this portion will be repeated. See, this one will be repeated here, keep on, and the same portion will be repeated here. Therefore, domain. What about the domain? Domain is nothing but input x. What is the value of x? 0, 1, 2, 3, etc. It goes at this end and this end. So in this case, domain is R. Set of all real number. Range. When you see the graph, maximum value is 1. It appear here. And minimum value appear here. That is minus 1. So it lies between minus 1 comma plus 1. So the range, the output of sine x is maximum value 1 and minimum value minus 1. That is, sine x lies between minus 1 to plus 1. Sine x value lies between minus 1 to plus 1. So in this case the domain is R. Why I am telling R? Because the value of x in this curve, it goes this end and it goes this end. That is what domain R. Range, the output. So maximum value of sine x output is plus 1 and minimum value is minus 1. So the value of sine x lies between minus 1 to plus 1. This is what the range. Next, amplitude. What is mean by amplitude? In English, amplitude is nothing but like height. In this case, the maximum distance from the x-axis. This is what your x-axis, the maximum distance from x-axis. So this is what your maximum distance. What is this distance? It is 1 unit. It reaches a maximum value which is 1. So amplitude is 1 unit. So amplitude is nothing but maximum height, maximum distance from x-axis. Got it? So amplitude is 1 unit, maximum distance from x-axis. This is a maximum distance. This is x-axis, maximum distance. So this is 1 unit. Next, period. One complete cycle is a period. It starts 0 here and it goes up maximum value, it comes down 0 and further it comes down, it reaches the minimum value of minus 1 and goes up and reaches the starting point. So this 0, 90, 180, 270, 360. This is called a cycle. This is called one cycle which repeats on either side. This is called a period. This is called a period 0 to 2 pi. So this is, the length is 2 pi. The period is 2 pi. Okay. So here we discuss about domain, set of all x values, that is real number. It takes all your real values. And range, output, maximum value 1, minimum value minus 1, So the range will be -1 to +1, or the sin x value lies between -1 to +1. Amplitude, maximum distance from x-axis, which is 1 unit. See here, the dotted distance represent amplitude. Period, one cycle, one complete cycle gives a period which is 0 to 360 degree. So the period is 360 degree or 2 pi. Got it? Next, this is 0 to 90 and this is 180, 270, 360. When you draw a circle, see, when you draw sine curve in the form of a circle, this is 0 degree. Okay, this is 90 degree, 90 degree, 180 degree, 270 degree, 360 degree. Try to understand. This is 0 degree, 90 degree, 180 degree, 270 degree, 360 degree in the form of a cycle. See, 0 to 180 above x-axis, 0 to 180 above x-axis. So sin x is positive in first and second quadrant. Why we are telling sine curve is positive in first and second quadrant? Because from 0 to 180 degree it lies above x-axis. It lies above x-axis, so which is positive. Therefore see, 0 to 180 degree first quadrant, in second quadrant sin x is positive. Therefore sin x is positive in first quadrant and second quadrant. And sin x is negative in third and fourth quadrant, because after 180, 270, 360, till from 180 to 360 it lies below x-axis. So sin x is negative in third quadrant, that is 180 to 270 and 270 to 360. Okay, so what can you understand? Your sin x or sine curve which is positive in first and second quadrant, and it will be negative in third and fourth quadrant. So you must know the reason why we are telling sin x is positive in first and second quadrant, because 0 to 180 degree it lies above x-axis, and we are telling sine curve is negative third and fourth quadrant because after 180 to 360 it lies below x-axis. So sin x is negative in third and fourth quadrant. Is it clear? Properties of sine curve. Let us see the graph. See the graph. I can say sin x is continuous function. Sin x is continuous function because when you see the graph, it goes in a wave movement without any break. So keep on, it goes like this without any break. So sin x is continuous function. Sin x is continuous function. And sin x is an odd function. Why we are telling sin x is an odd function? Because it is symmetrical about the origin. What is mean by symmetric? When you fold the curve, maybe a curve like this, see, you have a curve like this, this is what your x-axis. Okay, when you fold it will be coincide, means it is symmetrical about x-axis. A curve will be like this, this is your y-axis. When you fold like this, when it coincide, it will be symmetrical about y-axis. Is it clear? Sometimes it won't be coincide when you fold like this or like this. But when you do first x-axis and then y-axis, it will be coincide. That is what symmetrical about origin. I will explain further. See, consider a curve. It will be like this. This is a parabola, you know. When you fold like this vertically, when you fold like this, when this one comes here or this one goes here, when I am going to fold like this part, okay, when it comes here, it will be coincide with this. So it is symmetrical about y-axis. When it is coincide, when you fold like this, okay. Otherwise, replace x by minus x, no change, then it will be symmetrical about y-axis. Is it clear? So when you fold like this, it will be coincide, or when you fold like this, this part will be coincide here, then symmetrical about y-axis. In a simple language, replace x by minus x, then there is no change in the function, then it is symmetrical about y-axis. So while seeing the curve, you may can say, or replacing like this, if there is no change in the function, you may can say symmetrical about y-axis. Next, I will consider the graph. This is also a kind of parabola. Okay, when you fold this part, when you fold like this, this part will be like this. When I fold, this will be coincide. When you fold like this, it will be coincide with this. So in this case, it is symmetrical about x-axis. Or when you replace y by minus y, no change in the function. Okay, then this is symmetrical about x-axis. So can you understand, when you vertically fold, it is no change means it is symmetrical about y-axis. When you fold horizontally, okay, when it coincide, it is symmetrical about x-axis. Now we will discuss about symmetrical about the origin. I have a curve like it will be like this, sine curve I will take, and it will go up. Okay, when you fold, this part will come here. Okay, it won't coincide. And fold again horizontally, it will be coincide. This part when comes here, it will be like this when you fold. So you wanted to fold horizontally and vertically, then it will be coincide, means symmetrical about the origin. Got it? So what is mean by symmetrical about the origin? You wanted to fold vertically and you wanted to fold horizontally, then it will be coincide. That is what symmetrical about the origin. Or if you fold first horizontally and then vertically, anyway when it coincide, okay, it is symmetrical about the origin. So in this case, your sine function is symmetrical about the origin. Therefore sine x is an odd function. In this case, sine x is an odd function since the graph is symmetrical about the origin. Got it? Since the graph is symmetrical about the origin. Got it? And the maximum value is, see the graph, it gives 1. Maximum value equal to 1 and minimum value equal to -1. See, I will repeat. When you see the graph, see, try to understand the graph. From the graph, the domain is R, because it takes all your x values. Range, it is lies between -1 to +1. So maximum value 1, minimum value -1 when you see the graph. So the range is -1 to +1. Amplitude, the distance, maximum distance from x-axis to the point, that is 1 unit. So amplitude is 1 unit. Period, one cycle from the graph, one cycle will be, see, one cycle will be 0 to 2 pi, that is the period. So the period is 2 pi or 360 degree. From the graph, you can understand sine x is positive in first quadrant and second quadrant because it lies above x-axis. And sine x is negative in third and fourth quadrant because it lies below x-axis. And sine x is a continuous function. So when you see the graph, there is no break in there. In between there is no break. So sine x is a continuous function. Sine x is an odd function because sine from the graph, it is symmetrical about the origin. Because you wanted to fold very first horizontal or vertical and then vertical or horizontal, then it will be coincide, means symmetrical about the origin. So in this case, the graph is, when you see or fold like in such a way, finally it will be coincide. So since the graph is symmetrical about the origin, therefore sine x is an odd function. And the maximum value 1 and minimum value -1. Okay, just go through the video one more time, then only you can able to understand about sine curve. Maximum number of people simply they are watching the video, or maybe they are go through the textbook. They won't bother about the values, how it comes, etc. When you understand in this way, everything depends on the graph. So depends on the graph only I can say about domain, range, period, and whether the function is positive or negative, continuous or not, even function, odd function, symmetrical property, maximum value, minimum value. So everything depends on the curve. You must know about the sine curve. From the sine curve only you wanted to say the values of these things. Then only easily you can able to remember, and then at the same time you can understand why we are telling the domain is real, or the range is between -1 and +1, or the maximum value, minimum value, even, odd, symmetric about the origin, positive, negative, etc. So from the graph only you wanted to say everything. So you wanted to understand the graph. So you should know how to draw the graph first of all, and from the graph you must know how to calculate these values. So it will be very comfortable to remember, and you won't get any confusion also at the same time and in the future. Is it clear? So this is what about sine x. We have so many points and properties, but mainly we discuss about domain, range, amplitude, period, whether the value of sine x is positive or negative, whether it is continuous function or not, and it is symmetrical about origin, and whether it is odd function or even function, and the maximum value and minimum value. Is it clear? This is what sine curve. Now we will talk about cosecant x. What is mean by cosecant x? Cosecant x is nothing but the reciprocal of sine x. Already we discussed about sine curve, about the domain, range, etc. See here, cosecant x, which is nothing but 1 by sine x. So when you see blindly, it is a fractional part. Sine x not equal to 0. When sine x will be 0, see the graph, 0, sine 0, 0, then 180 degree it will be 0, again 180, that is 360, 0, again 360 plus 180. So every multiple of 180 degree it gives 0. So I can say x will be n pi, where n belongs to z. So in this case, sine x will be 0 for every x equal to n pi, multiple of pi, where n belongs to z. Okay, why I am telling this one? In this case, what is domain? Okay, let us see the cosecant x curve. This is the cosecant x curve. When you see the cosecant x curve, it will be, it never lies between -1 and +1. See, I'll draw the sine x curve also. See, in this case I have sine x curve and cosecant x curve. The red color curve represents sine x curve, and green color represent cosecant x curve. See, the red color lies between -1 to +1. So the wave goes like this between -1 and +1. And the cosecant x green color represent above -1, above +1 and below -1, and it touches 1. Because sine 90 1, even cosecant 90 also 1. So it touches 1 at the same time. Is it clear? It never lies between -1 and +1. So the domain is set of all r value. It takes all your real numbers except n pi, because n pi it gives 0, no, sin x 0. So sin x 0 means it will be infinity. Okay, so infinity not in real number. So domain is set of all real number except n pi. Okay, domain is r minus n pi, n belongs to z. Why I am taking from the real number n pi? Because n pi, your sign will be 0. When sign will be 0 means 1 by 0 will be infinity. So it does not exist in real. Therefore cosecant x, whose domain, it takes set of all real number except n pi, multiple of pi, and the range. So when you see the graph, the range is, it lies above 1 unit above and below -1 unit. So it takes minus infinity comma -1, open interval minus infinity, till it takes -1, and it never lies between -1 and +1. So, and it starts from 1 comma infinity. Is it clear? So that is set of all real except minus 1 and plus 1. So you can represent your range is set of all real number except minus 1 and plus 1 in the open interval, or minus infinity comma minus 1 and 1 comma infinity. So for cosecant x, it never lies between minus 1 and plus 1. So the domain is set of all real number except n pi. You must know why we are removing n pi, because when you give multiple of pi, n belongs to z, it become infinity. So it does not exist. So domain is set of all real number except n pi. And the range is, it never lies between minus 1 and plus 1. So the value or the range for cosecant x will be minus infinity open interval, comma minus 1 closed, and 1 comma infinity 1 closed, infinity open, or the set of all real number except minus 1 and plus 1, because it never lies between minus 1 and plus 1. So can you understand about the domain and the range of cosecant x? Is it clear? Here also we discussed the domain value and the range value based on the graph. Based on the graph. Is it clear? So when you remember in such a way, easily you can able to recall yourself and you won't get any confusion also at the same time. Is it clear? So this is what cosecant x. So here we discuss about domain and range mainly. Is it clear? Now we will talk about sine inverse curve. Here let us take y equal to sine inverse x. Okay, here y equal to sine inverse x. That is, the curve will be like this. Here when you see the x value, it lies between minus 1 and plus 1, because the sine x whose range is minus 1 and plus 1. Can you remember? In sine x curve whose range is minus 1 and plus 1. So in this case the domain is minus 1 to plus 1. So it never cross minus 1 and plus 1. So it lies between minus 1 and plus 1. And the range will be, it will reach 90 degree and it will reach minus 90 degree. So it lies between minus 90 and plus 90. So in the graph itself we can able to understand. Therefore the domain will be minus 1 comma plus 1. So for sine inverse x, the domain set of all x value in this case is minus 1 and plus 1. That is what input or domain. And the range output will be minus 90 comma plus 90. So in this case the output of sine inverse x lies between minus 90 degree to plus 90 degree. So from the graph, this is what I drawn, and this is what the picture I gave here. This is the picture of sine inverse x. When you see here, so the horizontal, that is the domain in this case minus 1 to plus 1, and the range it reaches maximum 90 degree and minimum minus 90 degree. So the range is minus 90 degree to plus 90 degree. Is it clear? So for sine inverse x, don't think I read sine inverse x. So inverse, it will be 1 by sine x. 1 by sine x. Your sine inverse x is not 1 by sine x. This is different and this is different. This is an angle. See, y equal to sine inverse x. So what is sine inverse x? When sine x, see, when this is y equal to sine x means sine x. It is a numerical value. 1 by numerical value is a blindly it gives some value. Okay, it's output. When the sine comes here, sine inverse y equal to x. So what is sine inverse? X. In this case x is nothing but an angle. Okay, this is different, this is different. Many students having a doubt whether can I write sine inverse x as 1 by sine x. See, 1 by sine x is completely different from sine inverse x. Okay, we are giving 1 by sine x as cosecant x. It has different function, it has different structure, that is extremely different output. Sine inverse x is not like that. Why I am telling? Because sine x, when you give different values for x, it gives what is x here? When y equal to sine x means I am giving degree. So it has 0 degree, 20, 30, 40, 90. So I am giving degree. So x is degree. When I am giving sine of some angle or degree, it gives a value. So where y is the numerical value. So 1 by numerical value gives some other numerical value. Is it clear? But when the sine comes here, sine inverse y equal to x. What is x? X represent an angle. degree, the slope. So this is different from the numerical value. So don't get confused between 1 by sine x is sine inverse x. Everybody know 1 by sine x is cosecant x. Okay, but sine inverse, so blindly 5 inverse means 1 by 5, 10 inverse means 1 by 10. So why don't you say under multiplication sine inverse x as 1 by sine x? That is entirely different. Is it clear? This sine inverse x, which is not gives a numerical value like ordinary values, the output. It gives an angle, degree. It gives a numerical value. So this is different and this will be different. Just keep in mind. This is the sine inverse x curve whose domain is -1 to +1 and the range is -90 to +9. Now we will discuss about cosecant inverse function. Is it clear? In this case, y equal to cosecant inverse x. See the diagram. From the diagram, you can understand about the domain. Okay. See what is the output of cosecant x. Already we discussed. Set of all real number except -1 and +1. It never lies between -1 and +1. So the range is real number except -1 to +1 open interval. So in this case, the domain, when you see the graph, it takes all your values except -1 and +1. So domain is set of all real number removing -1 comma +1, or it takes all your values -∞, -1 and 1 comma infinity. So open at -∞ and +∞, closed at -1 and +1. So in this case, the domain is set of all real number except -1 to +1. Okay. So this is what the domain for cosecant inverse x. Range. So already the range is -90 to +90. It reaches a maximum value 90 degree and minimum value -90 degree. But in between 0 gives an infinity, so it does not belongs to 0. And the range is -90 comma +90. Closed interval. Remove 0. So in this case, the range lies between -90 to +90, excluding 0. Otherwise, -90 comma +90, excluding 0. So in any way. So for cosecant inverse x, from the diagram, you can say about the domain set of all real number except between -1 and +1. It never lies. And the range between -90 and +90 except 0, because 0 it becomes infinity. Is it clear? So this is what domain and range. So in this topic we discuss about sine curve, whose reciprocal cosecant, whose inverse sine inverse, and the reciprocal function inverse cosecant inverse. So in all the cases we discuss about mainly domain and range. For sine curve we discuss about domain, range, period, amplitude, odd, even, maximum value, minimum value, negative, positive, etc. everything. So this video, it gives a maximum information about sine curve and the functions of cosecant, cosecant inverse and sine inverse respectively. So go through the video completely, line by line, okay, scene by scene. Each point, try to understand everything about the explanation from the graph. You wanted to remember everything which is based on the graph. Then only easily you can able to remember, and you must know the reason also at the same time why we are giving such a values for these questions, which is completely based on the graph. Is it clear? Don't memorize, don't mug up, don't try to accept anything abstract. From the graph you can understand everything very clearly. Okay, all the very best, my dear students. Thank you.